Okay, so if you're a project manager on an AI initiative, your success really hinges on one thing more than pretty much anything else: your data. Seriously, get the data part right and you are on a fast track to some incredible results. But get it wrong and, well, let's just say you're in for a very rough ride. So let's dive in and make sure you've got the playbook for success.
This is the question that keeps so many of us up at night, right? You've got the budget, you've got the team, the business case is solid, and yet the project stalls out or just completely underdelivers. What is that hidden variable that trips up even the best managed AI projects?
That's it, right there. It's not always some super complex algorithm or a problem with the infrastructure. More often than not, the weakest link is the data strategy, or, the total lack of one. The success or failure of your model comes down to the data you feed it, period.
So to navigate all this, we're going to lean on a really powerful framework called the CPMAI methodology. Just think of it as our guide. It's a structured, data-first approach that makes sure we are asking all the right questions at exactly the right time.
Okay, first things first. Let's talk about the absolute foundation of building a reliable model: splitting your data the right way. And listen, this isn't just some technical step for the data scientists. It is a strategic move that you, as the project manager, absolutely need to understand.
So, the training data. This is basically the model's classroom. This is the biggest chunk of your information, and it's where the algorithm learns all the patterns, the relationships, and the rules for your specific problem. The quality and the amount of data here directly impacts how smart your model is going to get.
Next up, you've got the validation data set. Think of this as the model's tune-up station. While the model is learning, it uses this separate little slice of data to tweak its own internal settings. This is so crucial for preventing a really common problem called overfitting, which is basically where the model just memorizes the training data instead of actually learning the general patterns.
And finally, we have the test data. This is the final exam. The model has never, ever seen this information before, so how it performs here gives us the most honest, unbiased prediction of how it's going to behave out in the real world. This is your project's report card.
So how do you actually split it all up? Well, the exact percentages can definitely change from project to project, but a 70-15-15 split is a really solid starting point. This gives the model tons of data to learn from while still saving enough to properly tune it and give it that all-important final exam.
Okay, so this brings us to an actionable checklist. As the project manager, you need to be driving the conversation around these key questions, and you need to do it early and often. Do we actually have enough data? Is it any good? And how are we going to validate this thing? Are we using a simple split or something more advanced like cross-validation? That's where the model gets tested against a bunch of different data slices to get a more robust score. Answering these questions up front is going to save you massive headaches down the road, I promise.
Now let's switch gears a bit. Let's apply these data principles to a really specific scenario: putting models on edge devices, things like sensors or your smartphone. Because when your model leaves the safety of the cloud, it brings a whole new world of data constraints to your project.
And this comparison here makes the challenges crystal clear. On the edge, you just don't have the luxury of constant internet or massive computing power. Data access might be spotty at best, and pushing updates is super tricky. Your model has to be small, efficient, and pretty much self-sufficient.
So, if your project involves the edge, this checklist is going to be your best friend. You have to define the hard limits on model size, plan for how data is going to be captured and stored right on the device, and figure out a rock-solid update strategy. And these aren't just technical details for the engineers. They are core project requirements.
All right, let's shift to another big strategic choice: using a pre-trained model. I mean, why build a complex model totally from scratch if a really powerful one already exists, right? But, and this is a big but, using one correctly requires its own data-centric evaluation. You can't just plug and play.
This four-step process is your guide. First, you got to do your homework. Where did this model come from? And what data was it trained on? Is that data even relevant to you? Second, you have to test it with your data. Does it actually work for your use case? Third, you need a plan for fine-tuning it to adapt it to your world. And finally, you have to keep a close eye on its performance and cost over time.
Okay, we have covered a lot of ground, and it all comes down to this: a critical decision gate you have to pass before you commit serious time and money to actually building a model. This is the data feasibility test.
I really can't stress this enough. So many failed AR projects could have been saved right at this step. This isn't just a suggestion.
It's a hard requirement. You have to be ruthlessly honest with yourself and your team about whether you truly have the data you need to succeed.
And here is the test itself. It's so simple, but it's incredibly powerful. Number 1, is the right data even available? Does it measure what you think it measures? 2, do you have enough of it, and can you actually get to it? And 3, is the quality good enough to even be useful? If the answer to any of these is a no-go, you have to stop, full stop, and solve that data problem first.
You know, this quote from the CPMI methodology just says it all. Without that solid data foundation, you risk building a technically perfect model that solves the completely wrong problem, or even worse, provides no real value at all. So, as we wrap this up, I want to leave you with this one question. Take a hard look at whatever AI project you're working on right now. Go through the things we've talked about. Are you actively managing your data requirements as a core part of the project? Or are you just kind of hoping for the best? Because when it comes to AI, hope is not a strategy.